Hi guys, I hope you are doing great, right? So, yeah, still nobody has entered. So, today is day 5 of Arduino Workshop, and today we will be learning, not learning, today we will not learn anything. Whatever we have learned, we will try to implement and try to make some fun projects out of it. Okay, now let me wait for students. Hello, hello Manoj, how are you? So, like from past 4 days, whatever we have learned, and you got 1 day of break also, right? So we will try to have fun. We'll try to make some fun projects today and we'll enjoy. Okay. Today's task is just to enjoy. Okay. I am also fine, Manoj. So, did you come up with any ideas during yesterday, like during weekends? How many people have joined today? Okay, only four. Okay. We will wait for 10 minutes more and then we will start with the class, today's class. Okay. So I will make um, I recommend you to open your Tinkercad and keep it ready because today we need to rush little bit because I planned of making many fun projects today by which you will enjoy. So yeah. By then I'll keep few things ready. Breadboard. One thing is ready. Then what else? Nothing. It's okay. So we'll wait for more 10 minutes and then we will start with the class. Okay. So did you guys came up with any ideas? Let me know. Hi Kiran. Hi Monica. So guys, did you came up with any ideas, any kind of projects which you want to make out of this or whatever we have learned? Okay, guys. So I am Oga. So we will wait for more like 6 minutes and then we will start. Okay, Kiran, to develop the career farming by the lot in the particular like urban areas. Yeah, you can. Terrace farming, see, there's a one of the best option which you can go with is hydroponics. Why? Because terrace like places they will be having limited space and you can't grow plants because if you know a plant root can easily break the roof if it penetrates in the crack of the cements and it starts spreading. So I will not recommend you to put soil and then put plants and then make it grow. Advantage will be like the room will be cool, but for long term I will never recommend to put soil and grow the plants. So better will be go with hydroponics, which you can do with Arduino also. So basically what is hydroponics, if I tell you in general, basically what happens like hydro means water, right? So you will have a long pipes where you will be having cups, which in which you will be having plants, and then the water, nutrient water, will be keep on flowing through it. And what will happen? The root will take suck up all the nutrient from that water, and it will keep on growing. So by which what is happening? You are not making anything dirty because there is no soil in it to grow the plants, and it is easier also. But there will be one difficulty which you might face is like too much of power supply you require because the pump should constantly keep on moving. So you need to figure it out how can you solve that part. And then if you're a fish, like if you have a craze of keeping fish as a pet, like if you have aquarium hobby kind of things, then you can mix that hydroponic with the aquarium. What will happen? Whatever the nutrient will come from the fish will go to plant, and again the filtered water will come to back to the fish. So by which it is beneficial for the fish also, and it is beneficial for the plants also to grow. So in this way, you can make hydroponics, and in urban area, this kind of things are way more popular. Not in terrace, but inside the building. Like there will be like since there is no soil, the plants are grown like what is it, like a rack. There will be, you will be having multiple racks where you will be like growing the plants. Okay. So this is one of the great idea which you can go with. And if you need help, message me. I will help you out how to do. Else, you can just Google search how to make a hydroponic system. You will get to know. You can add a ESP with it, by which you can ESP or Bluetooth or anything. Then you can make a mobile application where you can see and you can control. You can plant water, anything, whatever you want to do throughout anywhere of the world, anywhere from the world. Okay, these things you can do. So yeah, any more doubts or any more ideas which you want to execute it? Let me know. No, it's not. See, we can say it's not natural because we are growing the plant in artificial way, but we are not adding any more like any what to say, we are not mixing any chemical. Everything is growing in naturally. Just the only difference is the plant grows in soil, but in hydroponics, plant grow in the water. But you will be having a sponge which will be holding the entire plant, and the root will think that okay, this is the soil, and it will start growing and it will start spreading. If I okay, let me show you a photo of hydroponics. Wait, let me Google search. Um, many of nowadays, many of the plants like vegetables which you are buying in the market, yeah, there's a high chance that that is coming through hydroponics only. Okay, I'll show you. See here, you can see in this place. Can you see? Like there is a plant. I will open in the new tab. See, you can see, and the soil is there. Then you can see the like the roots are going down, by which you are keeping the plant also clean. You are not making your hand also dirty. So people are using it in a very large scale. See, this is how in a factory grid places, this is how the plants will grow. Like rack, one to one rack, by which you are saving a lot of space also in the same amount of space you are growing a lot of plants. This can be achievable. You can make in smaller scale also, and one of our presidents is college people only, they have made and they got first prize in Pondicherry. You can see this kind of photos also. See, this is a homemade where they have taken a pipe where they are growing something like spinach, I guess spinach or cabbage, and okay, yeah, looks like that only. So see, People are there to make multiple things. Okay, to make a drone, which is the most stable, sir? See, I will ESP. See, Pro Mini. I will never recommend you to go with Pro Mini because it has a very less memory. So, and it is not that stable, which I feel because I have used Pro Mini in my satellite, which was launched by ISRO in last year, and I really struggled a lot. So I will not recommend anyone to go with Pro Mini. You can go with ESP32 with the 16 MB version. You get one version known as ESP32 E. Go with that version. You will able to achieve it seamlessly, like very smooth, like butter if you are planning to make a drone. But still, I will not recommend to go with ESP also. You get proper dedicated five flat controllers. You use that, but to control that, you can use this ESP or Arduino something like that. So by which you are protecting that circuit because we have specialized circuits just to move that drone back, forth, left, right, all those things. Just take that and commonly when you make a drone, you will be having a receiver also, right, to control with your remote. Just fix it with it, and you can come up with new things. Controlling flights, that only like controlling flights with ESP you can do, and if you can connect Geo5 in the drone, by which you can make it port forwarding and you can access it from globally. So you can sit in one place and you can control the drone from anywhere of the world. If until it has that interconnectivity, so you can do that. Try out, but it might be a little bit laggy or slow. So make sure that n- you are aware of all these things and you make the drone properly because since you are controlling the drone remotely from somewhere, you might not know what will happen, right? Okay, it's 7 o'clock. Should we start the class, guys? Like make sure that like let me know that everything is crystal clear here. My audio was clear till now. Everything you are not facing any issue, let me know. Then we'll start with the today's class. See, people are growing tomatoes also out of hydroponics. So let me know, guys. Should I start the class or not? Are you guys ready? Open a Tinkercad and be ready and let me know using just show thumbs up. Okay, before starting the class, I was testing few things. So let me delete it off. Yeah. Okay. Okay, so let's start today's class. So, let me do a small recap before starting the class. What all we have done till now? We have learned about digital and analog signals. Then we have learned about actuators and sensors and how all this work, basic things works. Then we learned about basic functions like void setup, void loop, digital write, analog write, digital read, analog read, all those things, right? Till now we were playing with IO ports like analog or digital ports, right? Now we will try with something new, like something great. Okay. So I will teach you today a tune function, T-U-N-E, tune, T-O-N-E, sorry, tone. I will teach you tone function. What is tone function? Tone is basically tone, high pitch, low pitch, all those things. So we will try to make piano today out of input pins. Like as I keep on clicking the input pins, the tone should be something else. Like basically today we will be making one piano. That is one project which we will be doing today. And then we will be going with soil moisture. Like whenever the soil is dry, the buzzer should beep, by which it will be reminding me to put water to plant. These two projects we will be going to make today. Okay? Are you guys interested to make these two projects with me? Let me know. So let me repeat again. Today we will be making a keyboard like a piano and we will play songs in it, and we will be making one more project which is known as like smart plant, like watering system, where based on the if it is less water it will notify us, by which we'll put water manually and we will start growing it. Okay, interested, let me know, then we'll start the class. Yeah, okay. Cloudy. Nice name. Okay, So again, select an Arduino board. So I will select Arduino. Bring that Arduino to the canvas. Then we need a buzzer because we want to play songs, right? So just type in the search box buzzer. Yeah, we got buzzer also. Okay. Will it will this buzzer is good for our application? Let me check once. I just don't want to give you spoiler, but yeah. Yeah, it's the same buzzer. Okay. Now you will be having a buzzer also now. And then now we need to make a keyboard. We need some keys, right? Like buttons. Getting my point. So let's take few buttons. Before taking the buttons, I will teach you one of the popular board which 90% of the people use when they are starting with this electronical journey. That is known as breadboard. How does a breadboard look like? Let me show you. BRED breadboard. So these are the breadboard looks in real life. Okay, this is a smaller one. You get a bigger one also. See, this is a bigger one. Now, what is this breadboard? Now, breadboard is a like a small tool. You can say kind of a tool which helps us to connect everything. Like example, till today, whatever in the class we have done, like connecting LED, all those things. In real life, we don't connect everything on air, right? We need to put it somewhere and make it connect, right? So that's why we use popularly breadboard to prototype the things. Whatever we have thinking, we will be prototyping that thing, right? So to prototype that thing, we will be using breadboard where we will connect each and everything and then we will start playing around with it. Okay, that is the main purpose of breadboard. Now, how does a breadboard function? Like if you see this breadboard, you will be having like how does it work? So I have an image here. If you can look closely to this image, okay, image is very bad quality. Yeah, okay, this is clear. If you see this breadboard, you can see this all the black color dots are connected. Like vertically and horizontally all the pins are connected to each other. Like example, if I connect anything in these two pins, if I connect, I guess you can see my mouse pointer, right? If I connect anything in these two pins, this entire reel of like wires will be connected. So I can connect anything around here, anything around here. Like example, if I show you here also, then the Tinkercad, see, the moment I hover on any of the pin, you can see all the pins are getting green. Why? Because all are of the same pin. Same case goes with this top and bottom part. Top and bottom part also has this in common. We use it for voltage, the common signals. You can see the moment I hover in that positive part, the entire row is getting green in color, right? And here also entire column gets green in color, and in between there's a divider to divide that north and south part. Okay, you got the point. How does a breadboard looks and how does it work? So what is the use of breadboard? Let me know, guys. So now we will be taking buttons, push buttons. Yeah, we'll take push buttons and we'll try to connect it. You also take few push buttons here to make a nice keyboard. Okay, one, two, three, four, five. How many? Like okay, we can take five pencils is fine. Okay, five pins, five buttons I have taken. Now I will connect few things in common. Now example, if you remember the diagram which we made, like pull up and pull down thing, we need just to repeat it once again. So what I will do, I will just connect all the positive to positive. Okay, what happened to my ID? It's not responding. Hey, what happened? Whoa, whoa. It's lagging. Oh, it's lagging a lot. Okay, there's an issue with the network, I guess. Let me reload it. Is my audio, everything is clear? Let me know, guys. because there's a network issue which I am facing towards this side. Mm, vomiting, correct. Shit. Okay, we will make it once again. No worries. Uh, breadboard, buzzer, button. I hope you are also doing along with me only, guys. Okay, I'll connect buzzer also here only. Better. Okay, now we'll start with the wiring thing. Now, if you remember the wiring, there was one positive and one negative. If I want to keep the all the pins, Arduino pins grounded to remove the noises, right? So first I'll start connecting all the wires. So you also keep on doing with me, guys. It will be fun. So I'll try to change the color of this. You might feel a little bit bored, but yeah, it is a time consuming thing. So keep doing with me, guys. Don't lose patience. Yeah, I have connected four wires to the pin. Now, as I told, see, environment has noises, right? To eliminate noises, what we should do? We should pull down, right? How to pull down is by putting a resistor. I will put a resistor here. Yeah, I'll take a resistor and I keep on connecting here. Because we can connect it this side also. Because anyhow, these two ends are same only, right? So it's better to put that side also. It's fine. And I keep on repeating this. Yeah. Now don't get confused, guys. See, connecting this side or this side, both are same for the push button, right? If you remember, right? So here I will connect this entire part with negative um, ground. So by which what we are doing here, we are eliminating all the noises, whatever is existing. Now we need to connect all the positive wires. So let's connect all the positive wires. Again, we'll connect it here only. Positive. Wait. We'll make it red color. So you guys have done till now, till here. Let me know, guys. Now I have connected this one also. Now buzzer is like buzzer is here, right? Now we should do something with the buzzer also. Buzzer negative, what I will do, I will just connect it to ground. Mm, yep. And buzzer positive, I will connect to any of the PWM pin because we want to play music. To play music, what we do? When an Arduino is trying to mimic analog signal, what we analog right? So here we are not using analog we will be using tune to play around with this. Okay. This is how our circuit will look like. Everything is clear. Let me know, guys. Did you understood till here what I did? Let me know. Then we will start with the coding part. Everything is clear. So let me give you context again. If you have joined just now, we are making a keyboard piano where we will be playing songs today based on the keys we keep on pressing. Okay. If comment me everything till here, you got everything correctly. If you tell yes, then I will proceed. Else I will explain again what I did here just now. So let me know, guys. Did you understood what I did? I just took five buttons and all the buttons I have connected to digital pins, and to remove noises, all the buttons I have connected to the ground with a resistor by which all the noise will be eliminated, and then as well as I have connected all the buttons other side to the positive pin by which it will keep on blinking. Okay, great. Okay, great, Cloudy. We'll start with the coding part now. Okay, now again we have five buttons, so let's type all the five buttons. I explained you one more thing. Instead of typing one by one, what can you do? You can make a for loop and you can write it down easily, right? So we will make const means constant integer value. Okay, what is a constant integer value? We will take keys. Okay, and we'll take all the pins. What are the pins here? We are using 2, 3, 4, 5, 6. Okay, so 2, comma 3, comma 4, comma 5, comma 6. Okay, we have taken all the five keys which we have, and we are taking a buzzer. So int buzzer. Okay, as we get buzz because bbotics, no. Buzz. Then buzzer is equal to what, in which pin we have connected the positive lead, we have connected to the pin number 9. So we'll just type pin number 9 and we'll start with the code. Now we should tell Arduino what are the things we need to do here. Buzzer is an output device or input device. Buzzer is an output device, right? We will be using output here. And we have five buttons. Five buttons will be input device where we will be taking inputs. Okay. Now let's start. Let's start now. Okay. Now we will start with the setup part. Okay, in word setup, we will be typing. We will be typing all the this okay. So what is the const? Okay, const means basically constant. Keep anything constant, not to change. Example, if I write int buzzer, this buzzer value is 9 right now, right? I can change this 9 to any other value. It can be changed, like now it is 9, it can be 10, it can be 12, anything. But if you are adding const in front of integer or any data type, what happens key, it is constant. Const means const constant, constant. You can't change whatever values you have given to this, it will be remaining same, it will not change. That is the use of const in any keyword. I can use const in front of buzzer also, or else I can remove this const also. It will not get any impact. Okay, so I hope you got to know. Who is this? Dish, Dish Bhushan. Okay, Dish Bhushan, did you got this point? Like why we use const means constant to fix a value to this variable because we don't want to change it. If you are planning to change it, then we should not put const. You just put integer and start typing. Okay, this is the one thing. Now, void setup. In void setup, what we need to do, we need to mention all the keyboards like the buttons as a input device, right? So we will go with for int I is equal to 0 and I should be smaller than 6. Oh no, not 6, 5. Because it will start with 0, no. So 0, 1, 2, 3, 4. Okay. Then I plus plus. Okay, I plus plus. Now we will start with the like pin mode. pin M capital MOD pin mode, where you are telling keys I. Okay, if okay, let's have Q&A, small Q&A. How much do you remember from the previous class? If I value is 3, what will be the value? If I value is 3, what will be the keys value? Like what will be the output of keys index value 3? What will be the number will come out in the output? Let me know, guys. Let me know, guys. Again, pin mode, buzzer, which is an output device. Yeah, that. Okay, guys, let me know. Like if the I value is 3, yes, correct. Who? Swati. Yeah, Swati. Great. So yeah, correct. So the 0, 1, 2, 3. 3 will be 5. Yeah, correct. So now we have void setup. We have told everything. What are the input pins? What are the output pins? We have mentioned everything. Now we will start with the coding part. Okay. Now loop, void loop. Are you able to see the code? Okay, let me zoom it. Wait, if you are facing issue, let me zoom it. Okay. Now void loop. In the void loop, we will keep on playing. Now, as I told, today we will be learning about a new function known as tone. Tone, tone. Now, what does a tone means? Tone is a function which generates a certain frequency as the given number. Okay, if you write tone and if you start a function, this is a function. It takes three parameters. Like it takes three things. What are the three things? First thing is pin. Which pin to use? We will tell a buzzer. Buzz. We have kept buzz, right? Buzz. Now, how hertz we should generate a sound? So, okay, I will take 440. Okay, 440 hertz, like 440 hertz noise I want to produce. Then for how long I want to produce? I will produce it for 200 milliseconds. Okay, 200 milliseconds is fine. As I told, 1000 milliseconds is equal to 1 second. So 200 means it's like very slow, like very fraction of second sound. Okay, let's play the sound and see everything is working properly or not. Uh, and let me know that you can hear the laptop sound or not. Okay. Were you able to hear the laptop sound? Let me know, guys. Like the buzzer sound. Are you able to hear that buzzer sound? Because I don't know if this does the audio is also transferred in YouTube Live or not from laptop. So that's why I'm asking. Nice. Yes. Okay. 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 Great. Thanks. Thanks, Kiran. Okay. Yeah. Okay. So now we will make a keyboard. Okay. So what we'll do? We will do some basic if-else condition. So like if button one, right? So digital read, right? To of course to read and write because buttons gives 1 or 0, right? So digital write, DIGITL digital, W capital W, digital write. Now digital write, what I should do, like pin number 1, right? So keys 0 is equal to high, or else I can put 1. Anything is fine. If it is high, what should I do? I should play a tone of tone to buzz. Tone will be of 440 again we will take, and then we will be keeping it for 200 milliseconds. It's fine. 200 milliseconds is fine. Okay. Else, what we'll do, if nothing is playing, we just close it. Okay. Yeah. Let us check once everything is working properly or not. Keys, there's a error here. Okay, what does the error says? Void loop, tone. Digital right. Oh, did you got the error? Where did I did it wrong? Can you tell me where did it wrong? Comment me, guys. Where did I did it wrong? What is this? Like, what is this entire thing? We are trying to take input from the buttons. Where is the mistake I have done? Can you tell me? Comment, guys. I have done wrong in pin number as a line number 12. What it says? It's a digital write, right? Here, what I am doing here, I am reading it from the value. I am not writing out, right? So digital read you should do. Okay, digital read. Getting my point? Digital read to read the value, right? Because I'm not writing value, I'm reading the value. That's why there's a yeah, correct. Jeevit, yeah, correct, Jeevit. So let's start. Okay, still it shows an error. Why it shows an error? Let's see. Yeah, can you see one more error? What I have done here? Here I have opened a bracket and here I have closed the bracket. But here also I have opened a bracket. Where did I close it? I didn't close it. So put that also and then let's start the code again. So all set. It's beeping, right? Which button we are taking right now? Key 0, key number 2. It kept on beeping even when we are not pressing. It irritates a lot. Terminal A, terminal 2. It is connected to ground. Okay. Let me try to fix this by connecting it here. And let me try to connect this ground to ground. Uh, okay, let me try again. Else, digital right, right, WRIT, right, digital right, B use a jet bus, comma 0. Let me start the simulation again. We have to take 5 switches only, but I am testing with one switch first. Why it is giving error? That only I am trying to rectify it here. Digital rate key number 0 is 2, and if I see, oh, sorry, I am working here and pin number 0 is this one. So, yep, okay, let's try once again. Why it is giving an error? I have connected ground, it should not trigger a false value. 220 ohms. Best alarm clock, sir. That's also true. Okay, we should rectify this error, right? Why it is happening. So if I connect this, yes, as we have one pre-built like circuit also, let us refer that and see. Okay, if I take this pre-built circuit, What they have done? They have also done the same thing only. Then why ours is not running? That's a very good question. Okay, let me refer again. Let me see what they have done and what we have done. Um, Terminal 1, Terminal B. Okay, it should work. Okay, here they have connected positive to negative. Wow. Okay, whatever they have done, let's try to mimic it by connecting positive of this to negative of the plate and negative of the plate to pin number 9, and let's see how does it react. It has no change. Why? Key is 0, which is pin number 2 digital. Okay, got it. There's an error in the code only. I'm reading digital read, right? Now it should work. And digital read, you are reading it, that these two values are correct or not. When here it got disconnected. Yeah, let's start again. Oh, fixed. It's working. Nice. Whew. No, there was an issue with the code first, and there was an issue with the connection. Here, like since we have lot of wires here, we were unable to find out. So okay, it's a good thing we identified where was the error. So let me make this wires far, by which it will be clear. We can see all the wires clearly. Okay. So let me make it far. Is it clear now? Can you see it clearly now? Let me know. And does it still look cluttery kind of thing? This was also fine. Whatever we have done earlier. The register was also fine. The thing was we did wrong with the coding part. That was the issue. Again, we'll test it once again. Yeah, it's working. Okay, now we have done with one key. Now we have to do with one, two, three, four, five. Five keys, right? Now we will go to the code again. We'll just make everything as normal. Now we have one if condition, right? For we need to make it for five. One, two, three, four, five. Now instead of if, since if condition, now we will do with else if. else if, else if, else if, else if. Okay. Now key number one, key number two, like basically index value one, index value two, index value three, index value four. As if none of the button press, it will make a like it will not make any sound. So we'll change the pitch. Now it is 440, right? 440 we will make one, then 490 we will make one. Then let's go with 520. Then we'll go with 560. Then we'll go with 600. Okay, this way we made a basic tune, right? As I told, tone function has three parameters: pin, which pin to control, how many hertz of frequency we should generate, and for how much long milliseconds we should run. Okay, now we will start it. Now it's done. So now let's play our keyboard and see. Oh, that first one sounds very bad, horrible. So we will okay, okay. What are the other? Well, 10 kilo ohms, no? I also make it 10 kilo ohms only. 10 kilo ohms. Yeah. Now let's see the sound. Is it a fun project? Did you like this? How to make this kind of keyboards? If you understood the code, what we have done, then it's really great. And did you understood the coding? And we did some mistakes and we learned from how to fix those mistakes, all those things, and we made a small fun project like the piano. Did you like it? If you liked it, do let me know. And do you have any confusions in this part? Then let us know. Then we will move on to the next project. Okay, this was one project which we did, a small musical piano. It can, in reality, it will be more crystal clear. Like here, it is like it annoys a lot, but in reality, it makes a very sweet sound. That's what we can do. We can put a capacitor to make it smooth. Oh my god. Yeah. Okay, we can wait. Yeah, we can wait. You also try, play around with it. Let me know. Today's class will stretch it a little bit. No worries. Everybody make it and start playing with it. Okay, I'll show you the code also here. If you are like if you forget the code, see this code, see this diagram, everything is next to you only. Make it. Okay, and let me know how many of you have finished this part, then we'll move on to the next project. Till then I will try to play around with this tone and we'll try to make some good tones. 500, 510, 520, 530. Okay. Let me play with my piano now. Almost all sound same only to me. Okay, what I will do, I will make it as 400. Okay, I will make it 480, then 540, 590, 620, 660. Now let me see how does. The last one is, I don't know why the last one is so bad. I'll try to make it like something higher, like 900. Let's see how does a 900 sounds like. Oh my god. Okay, then what we will do? 980, 880, 780, 680, 580. Now let's see. Oh my god, the sound was horrible. Ouch, it hurts. Okay, so I will request you, like since we are running out of time and we need to make one more project, take a screenshot of it, or else I will send it. I will only take a screenshot and I will send it in the group. Okay, let me send it in the group. You can continue with that, and let's move on to the next project, where we have planned to fish pot, no, not fish pot, plant pot. Whenever the soil moisture is less, the it should keep beeping, by which we'll get to know that okay, we need to put water to the plant. Okay, this is the one thing which we'll be doing. But one catch, one small catch. Sir, phone speaker. This phone speaker ಆಗುತ್ತೆ sir. Okay, like are you asking like can you put phone speaker, or like you're like saying like your phone speaker got bird and like something like, can you explain in which context you're trying to say? Yeah, are you asking that can you put phone speaker jack, or are you asking like it has gone? Okay, we will go with the next code. So in now what we will be doing, we will be taking two things. One is soil moisture sensor and one is LDR. What is LDR? Okay, let me know before starting with the LDR. What is the full form of LED? LED means light emitting diode, right? LED means light emitting diode, which emits some light. Now LDR, light resistive diode. Now example, in yesterday's class we learned about potentiometer, right? Whenever we change the potentiometer value, the brightness, like the light increase, like the resistivity increase or decrease the way we rotate it. The same way LDR, light dependent resistor, changes the resistivity based on the amount of light falling on it. The more light falls, it will become less resistive. The more there's no light, it will become high resistive. So based on that calculations, what we will be doing, we will be identifying it's a daytime or night time. Okay, that is the first thing. A day or night we can identify from it. Second thing, what we need to identify, does the soil has water or not? If the first it will check if it is day or not. If it is day, then it will check is there is water in the soil or not. If it is there is no water, it will buzz. If it is night time, it will not buzz by because imagine the soil got dried and you are sleeping and suddenly it starts buzzing. It will disturb your sleep, right? So that's why we will make sure that its LDR is connected, and LDR is used to identify day and night, and we'll be using soil moisture sensor to identify like its moisture is available in the water or not. Okay, then let's start with it. Delete everything. Now we need a soil sensor, so I'll just type soil. Now we got a soil sensor. We'll connect it, take it. Then we need a LDR as I told. LDR. Okay. Oh shit! What happened? L. Okay, I'm not getting LDR. I don't know what is it named as. Okay, it is written as photo registers. Okay, photo register also fine. No issues. This is a small photo register which you can see it properly. This is how it looks in real life also, which will keep changing its resistivity based on the thing. Okay, now I will keep the signal here and I will keep this register also here only, pakka of it. And then I will start connecting the wires. Okay, now one of the register wire will be going to positive end Okay, and then another end will be, it will be going to analog. Why analog? Because we want analog. Now, as I told, analog will be having some noises, right? It might have some noise, right? So how to prevent it? We'll be connecting a resistor here. Now we'll take a resistor also, which will be connected to the analog pin, which let us keep it to 20 ohms. And I will connect this part to the ground by which all the noises will be removed. Okay, finished. Like what you have finished, Amog. And tell me what have you finished? Did you finish making that piano thing or you have finished this LDR thing? Then here also you can see, if you look closely, here is like VCC, GND and SIG. Now SIG means signal pin, GND means ground pin, VCC means positive pin. So it comes already with register step, like all those things. So we know to connect. We can connect directly to the board also, no issues. Okay, we can connect this directly to the board also. So I will just take power voltage and I will connect it to 5 volts. It will be connected to the 5 volts, ground to ground. Now signal pin will go and connect it with A1. Okay. Okay, so as you can see, there is one LDR and there is one like soil moisture sensor. So based on these two parameters, we will be identifying it's day or night, or there's a soil in like there's a water in the soil or not. Okay. Now we will take some buzzer to annoy us. So I'll go to components. Buzzer. Where is buzzer? Video clarity is low. I have proper internet connectivity. Just go to the like YouTube settings and try to increase the video quality. It will work. From my end, like everything is fine today. Check one side, like check once towards your side also. Now we'll put buzzer. Okay. So buzzer negative will connect to the ground. Here we have a negative pin. So black, and then we'll be connecting to pin number 11, because pin number 11 is a PWM pin, right? Okay, this is how your circuit is done. Let me know, let me zoom and show you again. See, there's a signal pin going to the A0, and to reduce all the noise we have a like a register to reduce all the noise. And then we have connected the positive end to the 5 volts signal pin. We have not connected any resistor because you can see there's an inbuilt resistor here in this sensor. So we have directly connected signal to A1, ground to ground, and positive to positive. Okay, these three things we have connected. Now these are the two sensors which we have taken to take environmental signals. Now we have one buzzer to notify us that there is low water. Okay, now we will go with the coding part. Okay, now let's go with the coding part here. Again, we have a buzzer. So int buzz is equal to pin number 11. It is going to pin number 11. Okay, then we have two sensors, right? Int soil sensor. So I will type soil is equal to, soil is connected to which pin? Let's us see. Soil is connected to pin number A1. Okay, we'll add A1. Then int, again we have LDR to identify the sunlight intensity. It's day or to identify day or night. A0. Okay, got it. Now we don't know what will be the analog values. It can be anything. So before we start, we will test like what is the value which has been given by this all devices. Okay, so to debug, this is only debugging. So to debugging, what we will be doing is serial communication, as I told in my day 2 class. Serial communication, where you communicate with the two Arduino boards using serial communication of multiple baud rates, like in how much speed it will talk. Generally we take 9600. Okay, so we will start void setup. In void setup we will be going with pin serial ACRL serial dot begin with 9600. Generally we use 9600. There's no meaning like why 9600, because that is the like that is the most popular one. Like if I show you the Arduino ID, how does it look like? Just type Arduino. Like I have installed. Once we'll be having offline classes, then it will be more like interactive, and we can make multiple projects. So here this is how the Arduino ID looks in reality. So if you go here, tools, and if you see the baud rate here, like where is the baud rate? Okay, here it is not there. Here we don't have option of selecting baud rate. Okay, so if you can see here uploading baud rate also, there are multiple numbers. One of the general one which we use is 115200. It is a high very speed one, and this is a code. If you see this part of code, this is a code for turning on and off a hydrophonic system, like which we were talking regarding at the first of the class. Okay, this is how the Arduino ID looks like. We will be doing, you will be using the software on the day when we will be having an offline class with the real Arduino boards in hand. Okay, now for debugging we have taken serial pins. Now we have two input and one output pin, so we should mention that also. Pin mode, mod pin mode, we have buzzer. Okay, bus, we have taken bus, which is an input or output device. It's output device. So UT output device. Okay. Now we have two more pins, soil and LDR, which will be input pin. Okay. Pin mode, soil is an input device. Okay. Pin mode, LDR is an input device. Okay, these are two inputs, and buzzer is an output device. Getting my point? Then after this, now we need to read all the values, like what is the value we are getting here. So by which we can start mapping it. Okay. So void loop. What I will do is just I will do serial print ACR serial dot print print. I'll just print. I'm not print. I'm just typing print soil. I want to see soil value. How much is the soil value? And I will print ACR serial dot print ln, where I will be printing the soil value. What is the soil value? Soil is soil. Sorry. In analog, read what? Soil. And I will just print it off. Okay. The same thing goes with LDR also. Sunlight. And here it will go with LDR. Okay. Now let's start. Let's play the code and see how does it respond. So we will open the serial monitor here. You can see sunlight is showing 1 and soil is showing 0. So now we will try to change the value and see. Okay, it is increasing. As you can see, the highest, if the water is, if the soil density is the highest water, we can say it is showing 876, right? 876 is our highest. Okay, highest, and lowest was 0, right? Now we will go with the LDR thing also. Now LDR is showing 1. So we will take minimum as 1. We will write it down. And if we try to increase the sunlight intensity, LDR is also showing around 876. Oh, both are showing this. No, LDR is showing 310. 310 is the max it is showing. Okay. Okay. Now sunlight is going to 0 to as sorry 1 to 310. It is going max, and the lowest it is going to 1, right? Sunlight. And the soil sensor, it is going max to 876, and the lowest it is going to 0. Okay, these two things. Okay, now since we got to know the range, now based on this we will be trying to make our code. Okay, now what we will do, we will just make a if condition. If sunlight, like we saw, right? Sunlight, so the analog read in read analog read sunlight, we just told, right? It's a day or night, we should identify. Sunlight is LDR. Okay, if we say analog read LDR, then if the LDR value is greater than, we forgot what was the like highest value it goes to 310, right? So what we will do, if the sunlight is about 200. Okay, if the sunlight is about 200, it means it's a daytime. Okay, print print, sorry, serial dot print, and then we'll print the print ln, it's daytime. Okay, it's a daytime. Okay, now what we'll do, since we got to know it's a daytime, now we want to check the soil sensor. Okay, now we say the soil sensor, so we will again put a if condition. If analog read, if analog read soil, like whatever soil is, the soil value max it went to 860, right? So 876, so what we'll do, we will take 500. If the value of soil is less than 500, basically if less than 500 means it is dry, right? So we will print ACRIL serial dot print ln soil is dry. Soil is dry. Okay, else we'll print ACRIL serial print ln all fine. Now here also, like if we are using analog signals, we can take particular, like how much level of water does the soil require. That also we can play around with. Okay, got it. So we have a LDR value to identify day or night, and we have a soil sensor value to read and identify it's a day or night time. Okay, now we'll buzz it. So if it is dry, we'll buzz. So we'll write digital write, DIGITL, digital write, WRIT, right? Digital write, where we'll be having soil, not soil, buzzer, BUZZ, which will be on whenever it is dry, or else it will be off. Okay, got it. Now let's run the code and see. Okay, let's run the code. So yeah, now we will try to increase the day. Now we will go above slowly. Now it shows that it's a daytime and it's buzzing also, right? Why? Because how much is soil value? Soil is dry. Now I will increase the soil value. Now see, the moment I have increased the soil value, the buzzer has stopped. It has stopped annoying us, right? I will make it clear here. Let me show you once again. Okay, the moment I make it as a daytime, you can see here it is written it's a day. Like, I just stop it. You can see it shows it's a daytime and the soil is dry. So what we will do, we will try to increase it. So okay, here also we should increase daytime and the soil is still dry. So what I will do, I will try to increase. The moment there is a more soil, so the time, sorry guys. So when there is a there is too much of water, you can see that the soil is wet, and like the soil is wet. That's why now there is no buzzer. A buzzer is not annoying us, right? Again, if I reduce it, yeah, got my point. Now let me know if you understood till here, and then we will we will again try to recap everything whatever we have learned today. Okay, did you understood this part? Let me know, guys. And are you also making the same thing? So what we have done in this project, we have taken two sensors, LDR and soil moisture sensor. Soil moisture sensor to identify the level of water content in a soil. Okay, and we to identify it's a daytime or a night time. Okay, then we have taken a buzzer to annoy us whenever the plant is dry. It will keep on buzzing, by which we will get to know that okay, we should put water to the plant, and we can go and put water to the plant. Okay, did you understand everything till now? Let me know, guys. Did you understand everything? I'll just take a screenshot of this also and I'll put it in the group. Let me know, guys. Any doubts if you have. All is everything is clear. Yeah. Okay. Great. Any more people like did you understood what we have done today and are you able to do the same thing? Let me know, guys. Okay. So what I will do, I will start revising whatever we have done till today. So basically, we have done two projects today. One, we have made a keyboard like a piano to play songs, and one other project we have done is plant water like notification system, which will remind us to put water to a plant, but in a condition whenever it is a daytime, not at the night time. This is the two projects which we have done where we have integrated sensors and input and output device, and we have tried to play with the signals, and we understood about the analog and digital signals. Okay, now, if I take a if I take a recap of this code only, you can see there are two analog pins I have entered A1 and A0, and we have used serial monitor to read whatever the Arduino is printing. Then we have mentioned output and input device, and we have given a threshold. If it is more than 200, it means it's a daytime. If it is less, it is a night time. Right. And if it is daytime, then again inside that if condition, again we are doing another if. This is known as nested conditions, nested if conditions. Okay. There's another if where we are seeing the analog signals. If it is below 500, it means the soil is dry. So it will start buzzing. If it is not dry, it will be like, ah, I'm fine, everything is fine. Okay. I hope you have understood the coding part, right? And you have understood this circuit designing also. Why we have used resistor to reduce noise, all those things. Got it? So I hope you enjoyed today's class. Let me know any doubts if you have. And today's homework. Oh yeah, today's homework. What should I give today's homework? Hmm. Okay. You also do the same thing with a LED indicator. What you do? Like okay. Show soil moisture level using 5 LEDs and plant water reminder. So I have given today's homework to you guys. Let do this homework and send me with a name and roll number, and I will notify this to Ramesh sir. Okay. So this is today's homework. I hope you will come up with a good project. Since we learned about mapping functions, since we learned about analog signals, all those things, based on that you can play around with this LEDs. Yesterday, if you remember, like on Saturday's class, we were rotating the potentiometer and we were turning on and off the LEDs, right? The same thing you can do it here also. Just you need to show the soil, like soil moisture level in the LED. Okay, and you should make it burst whenever it is dry. Got my points? Okay. So I hope you enjoyed today's class. You have learned something new. Let me know, guys, if you have enjoyed, and meet you guys in tomorrow's class. Okay, in tomorrow's class again we'll come up with few more projects. Okay, bye bye. Have a great evening.